right, so Dexter has invested in an annuity. So we just remember, an annuity is when you have a certain amount of money, you put it into the bank, it's going to get interest. So they're going to make you money, so you get extra on it, but you will start taking payments out because you also want to use your money. So although it's gaining a bit, you're taking some out. That's what an annuity is, and it'll keep going until it zeroes out. Okay, so he invested in an annuity that earns interest rate of 4% per annum, compounding monthly. So you might straight away, I like to say, all right, here's I, and I know PPY is 12. He receives monthly payments from the annuity, yep, and after 1 year, so 1 year the balance is this, and after 2 years the balance is that. So it says the monthly payments is that he has is what? So once again, payments is the question. So I'm going to write out my finance solver, all my little categories, and I'm going to put the question mark on the payment, so I know that's the one I've got to find, and I must be able to get everything else. So off I go and I try. So PPY I know is 12, and the interest rate I know is 4.9. So now I need to work out all the other little bits. And what I'm going to do here is because I've got 1 year, what's something happening at 1 year, and then I've got after 2 years, which means I actually have a year time slot. So I'm going to pretend that this is the start. Okay, so I'm going to say, all right, that's the start. I'm pretending that I'm investing at that point. So if I'm investing, it's a negative amount of money, and I put it into the investment there. And then I've put what the final value is after that year. So that would be what, the year 2. So I'm going to say this is what the bank would give me back after that 1 year. Now, because it's a 1 year in between, I'm going to put 12 monthly payments into there. So I can go do that on the calculator and find out what the month. So we found 799, sorry. So they're 88. If you're given 2 years or 2 time slots, you can pretend that one's the start and one's the end, and then you can work out the time in between like that. So that's a good example. It's probably a nice one. I'd probably have this one, maybe a reference book, to remind me that I could do that if I have that scenario. All right, let's go to this next one. A delivery company purchases a van for $44,800. The van is depreciated at a rate of 35 cents per kilometre. So just always change these cents things to dollars, because we're going to talk in dollars. The company replaces the van when their depreciated value reaches 10,000. The number of kilometres this van is expected to travel is close to. So this one, you can really logically sort of work it out. So you've got 44,800, that's what it is, and you're going to minus 35 cents for every kilometre. And we want to know, when does this reach 10,000? How many kilometres? So you can see I've set up an equation there. So now you can just simply shove that into solve, comma K, and you will get that on the calc. Here, K's that, so it's closest to that, 99,000 kilometres. All right, all good.